welcome to our Supermicro session. My name is Jared Dien, the Director of System Solutions, and I have my colleague Jeff Liu, who's the Senior System Engineer. In today's session, we'll be discussing SUSE CaaS Platform 4.0 on the Supermicro platforms.
Thanks, Jerry. My name is Jeff Liu, work for Supermicro Product Office, Vertical Solutions. My job is to collaborate with partners, create, test, and validate solution reference architectures. Most importantly, help customer build a Supermicro hardware-based solution that offers the best combination of price and performance to do more with less.
Before I begin, I would like to take a brief moment to talk a little about Supermicro. We started as a server building block company, providing motherboards and chassis. Then, we integrated those parts together to offer server systems that provide the latest technology that offered in rack mounts, density nodes such as twin and super blades, storage, GPU, as well as embedded in IoT. As we fast forward to Supermicro 3.0, we now offer a full integration with a variety of software solutions and management capabilities.
Containers, Kubernetes, and microservices. Some think they are interruptive technologies. I don't want to repeat anything that you already know. Today's agenda is quite simple. Give you a 1,000-foot view of what SUSE CaaS platform is and how does it work with Supermicro's hardware. Let me start with the survey and marketing research. The first graph is done by CNCF, Cloud Native Computing Foundation. It shows the use of containers since 2016 when Kubernetes went to mainstream. As you can see, the container technology is crossing all stages of application development. In 2019, 90% of respondents are using container in software development. 88% of them are using container in test. Most notably, 84% of respondents are running container or Kubernetes in production, an impressive jump from 73% in 2018, a huge leap from only 23% in 2016. The second graph is a result of a marketing research provided by Statista. It shows that the estimated container worldwide market revenue in 2020 is about $2,714 million. Of course, we have minus impact of COVID-19. Nevertheless, both the CNCF survey and the Statista marketing research clearly indicate that more and more organizations are using container not only in software development, but also in customer-facing applications. It is nice to package an application and its dependencies into a container. The single object becomes portable, allows application to scale out, and runs anywhere, whether it's on a public clouds or private clouds or server. The worst I've seen is running from a developer's desktop. The problem is how to keep tracking and managing the container scattered all over the places. That's where the Kubernetes come into play. SUSE CaaS platform, aka Container as a Services. In a nutshell, it is a CNCF certified Kubernetes distribution which supports the latest version. The version I installed a couple of days ago for this demo is version 1.16.2. The latest stable release on the official website is version 1.18, so we're not far from it. According to SUSE, they will refresh the distribution after 90 days of the upstream release. The SUSE CaaS platform can be deployed onto a bare metal, VMware, KVM, and AWS. Together with the Supermicro, SUSE CaaS platform becomes a complete solution that has many advantages. First off, faster time to value. It is delivered as a complete package with everything needed to provide containerized services. Secondly, simplify management with a Scuba tool that automates Bootstrap, easily add and remove worker nodes from a cluster as needed. Last but not least, with unmodified Kubernetes upstream release, the solution will ensure the existing investment protected. There's no need to rip off a current system and rebuild entire cluster whenever a new release comes out. In addition to that, Supermicro also offers rack integration provisioning services, which is a near turnkey solution that you can simply roll the rack into the data center, plug in, power up. There you go. The platform is ready to use. So, simply put, the partnership between Supermicro and SUSE offers a turnkey container as a service platform solution without vendors lock-in. Let's take a look at what are the major components of SUSE CaaS platform. The table shows you the key components and functionalities. The 5 main components include installation, security, container runtime engine, UI, and monitoring. If anyone ever installed a Kubernetes cluster manually, you will know how tedious and error-prone the process can be. Scuba tool is an open source project initiated by SUSE, which leverages Kubernetes features to automate cluster bootstrap. It literally takes less than 10 minutes to initialize parking environment with one master and one worker. I'll show you a couple of recorded video clips in the last 2 slides. Most of you use the IP table at some point in time, a very powerful firewall applications to manage network security. Come to think of it, you have application deployed onto a CaaS cluster. Let's say you have 10 pods, each pod has 10 containers. You end up with 100 containers, plus different applications runs on different containers with different levels of security policies. How do you manage that by using IP tables? It is impossible. Cilium, as a robust container network interface plugin, is to resolve the scalability issues by implementing VXLAN for overlay network, using identity-aware security policies that only apply to worker nodes where I need them. It does not care what IP address and TCP ports are. It goes by Kubernetes labels, which seamlessly integrates with the Kubernetes role-based access control mechanism for security policies. It also encrypts all nodes communications regardless the nodes are deployed, known as cluster mesh, not just only for security, but also for load balancing. Docker, we all know, is the most popular container runtime engine, but Cryo is a lightweight container runtime engine designed specifically for Kubernetes. It consumes less resources. In turn, the system can reserve more resources for critical path operations. Stratus, it's a UI. It is a single pane of glasses for application delivery. It can create application instances, view application event logs, and perform application lifecycle actions such as start application, stop, and delete application once it's done. Of course, there are many other components which don't have time to go over all of them. How do those components work together? This slide is a simplified workflow that gives you an overview what's under the hood and how Kubernetes platform works in SUSE CaaS platform environment. Let's just do 2 quick walkthrough here, bootstrap and deploy applications. To bootstrap a Kubernetes cluster, the admin will launch a Scuba utility. It connects to the kubeadmin, and the kubeadmin is going to talk to load balancer. The load balancer is going to find your designated first master node. And they will pull all necessary Kubernetes components from repository like API server, key value store, Kubernetes, CRI-O, and Kuberproxy, and other components. Up to this point, the initialization is complete. When deploying applications, DevOps is going to talk to the Kubernetes clients, which is CTL, and CTL is going to talk to the load balancer. Load balancer is going to talk to API server. API server is going to check your database. So if it's not there, you can talk to scheduler, and then scheduler will talk to the worker node to find if there's resources. If there's resources, the scheduler can inform Kubernetes, and Kubernetes is going to instruct CRI-O, the container runtime engine, to pull all the images from authorized repository and then fire up the containers. Here you go, it pods is up and running. After the pods is running, your controller, you can monitor the pods. If anything goes wrong, the controller will restart the pods. That's pretty much it. Please pay attention to the middle part. It's called storage services. Kubernetes storage class or volume plugin can use many different types of storage. SUSE CaaS platform perfectly integrates with the SUSE enterprise storage, which is Ceph cluster. You can use Ceph storage as a PV as well as a PVC. There are 3 different ways to deploy SUSE CaaS platform. In Pocket demo model, it only requires 1 master and 1 worker node. For high availability model, it requires a minimum 6 nodes, which are 3 masters, 2 load balancers, and at least 1 worker node. If HA is required for key value store, ACD, and then more nodes are needed. For air-gapped model or DMZ style, if you prefer, which means the SUSE CaaS platform or your Kubernetes cluster is totally isolated from the general public internet, including some of your internal networks. So you have to bring the software repository in-house somewhere in your DMZ for setting up and configuring the cluster. Regardless which scenario you choose, admin nodes is always required, which is where you run Scuba tools and the Kubernetes client from. The nice thing to have a dedicated admin node is that you can manage multiple clusters from that station. Also, you need to plan ahead with IP range properly, just to be sure there will be no duplicate subnets internally, so you have to use NAT. DNS is critical for you to configure Kubernetes. The same is true to Ceph, to OpenStack. DNS is a way to avoid editing host file and makes your life a lot easier. Working with SUSE, Supermicro has come up with a very solid and cost-effective reference architecture. This is a validated, fully tested container as a services solution that built with Supermicro Super Server and Ethernet switches. The rack elevation view kind of giving you an idea what's being used for reference architecture. There are 4 switches, 2 for management and 2 for data traffic. The Ethernet switch can run either Supermicro industry standard OSs or Cumulus Linux open network operating system. Also, we have 1 admin node, 3 master and 5 worker nodes. From a density perspective, the cluster only takes up 13 RUs. Even with 2 load balancers, it is still a very small footprint, 15 RU. So a customer can scale up by adding more worker nodes into the same rack, or scale out by install a rack besides the first one. With highly scalable Supermicro Ultra, Big Twin, and storage servers, supporting up to 44 CPU cores, 3 terabytes of memory, high performance NVMe storage on each node, the flexibility of network configuration with SFP plus 10G base T, and 40G and InfiniBand, which making Supermicro hardware a perfect choice for SUSE-based CaaS platform. With the proper specification, this 3-master nodes cluster can easily manage 500 worker nodes. The network diagram shows the network configuration for this reference architecture with the MLAG used between data switches and dual NIC bonding on the cluster nodes. You can achieve high redundancy and availability. MLAG also can avoid traditional spinning tree that might introduce network instability. The underlay physical infrastructure shown here can very well support overlay network that's required by containerized applications. Here's a SKU used in reference architecture: one standard 42RU data center rack, one 5019P, a single socket super server that optimized for DB processing, data center, and firewall applications, 8 1619U, a dual socket ultra server which is geared toward virtualization, computing, and high-end enterprise applications, 2 G3640B Supermicro bare metal switches, which is an ideal TAR switch for data center. It has reverse airflow option, one-to-one non-blocking connectivity, and hot swappable power supplies. With the Cumulus Linux open network operating system that allows you to automate, customize, and scale up your network easily. It supports EVPN, virtual route forwarding, and many features that data center needed. SUSE CaaS Platform 4 only works with /15 SP1. This is why we have a nice subscription here. The last one is a rack integration service that I mentioned previously. We rack and stack and perform burn-in tests on our production floor. We also provide extensive detailed inventory report, install and configure the platform per your requirement. We'll do the heavy lifting work here, so you can have your talent to do what they do best instead of spending weeks on mounting the rack, patching cables, testing, and collecting hardware information. Please note the reference architecture only have the network and servers. If a cluster node needs more storage space, we can add storage nodes there. It also can integrate with Ceph, which you could get unlimited storage space. Just as we're currently working on reference architecture that will run AI and machine learning applications with GPU over SUSE CaaS platform. So please stay tuned.
If you're looking for an AI or machine learning architecture, this reference architecture is ready to deploy end-to-end solution that includes the AI software stack, orchestration, and containers. The optimized reference design fits machine learning training and inference applications. The application on a high level comprises software, network switches, control, compute, storage, and support services. This reference design contains 2 data switches, 2 management switches, 3 infrastructure nodes, and 6 cloud nodes. It is built on Kubernetes platform and provides canonical hardened packages for Kubernetes, containers, and Ceph. Kubeflow provides the machine learning toolkit for Kubernetes. We offer several servers for the master nodes as well as the cloud nodes. In the master nodes, if you're looking for a single node that can handle a mixed variety of workloads, look no further than our 1U Ultra Rack Mount. The SYS1619U TN4RT is a dual-socketed platform that can support up to 6 terabytes of memory, 4 expansion slots, and 4 full hybrid drives for NVMe and SATA support. If you're looking for node density, our Big Twin SYS2029BT HNC0R has 4 hot swappable nodes with redundant power supplies in a 2U form factor. As we take a look at the cloud nodes, our 2U GPU server, the SYS2029GPTR, is an ideal choice for training and inferencing. This server can support up to 6 NVIDIA V100s. The Ultra SYS 6029U TR4T is a scalable 2U platform. It's a dual-socketed server that can support up to 2 NVIDIA V100s or 4 NVIDIA T4 GPUs through optional risers. It has 12 3.5-inch drive bays, which can easily support up to 40 to 50 terabytes of storage on each node. This is an ideal choice for a balanced workload. Our Big Twin 2029 BT HNC0R has 4 hot swappable nodes in a 2U form factor. Each node supports a processor and NVIDIA T4 GPU. This is ideal for high density and heavy computing workloads or inferencing workloads. Our reference design allows mix and match of these server models for the cloud nodes. For example, you can have 6 2029 GPTRs for training workloads and 6 6029Us TR4Ts for a balanced workload and 6 Big Twin nodes for handling inferencing in a single cluster. Lecture examples only showed you a glimpse of Supermicro's product offering. As a leader in the IT industry, we have the breadth and depth of overall solutions ranging from rack mounts, multi-nodes, storage, GPU, and edge computing. All this targeting various workloads in enterprise, cloud and web, storage, hyperconvergence, AI, machine learning, and HPC applications. Our flagship Ultra comes in a 1U and 2U form factor. We offer some of the highest densities of 2.5-inch NVMe support in the 1U and 2U rack mounts. Our modular design provides standardizing on one motherboard design throughout the whole series. By leveraging our proprietary risers and versatile storage configurations, we can consolidate many system requirements down to a few Ultra platforms, saving you logistics and serviceability due to the modular design. The latest Ultra to join the ranks is our 2U short depth at 22.6 inches. Ultra platforms will support the latest dual Xeon processors at up to 205 watts. With the 24 DIMMs, we support up to 6 terabytes of memory and up to 9 terabytes when using DCPMM. NVMe, SAS, and SATA are all supported throughout our configurations. 1U can accommodate up to 4 PCI Express slots, while 2U supports up to 8 PCI Express slots. The Ultra can also support a variety of GPU configurations with optional risers. Each server has redundant power supplies with AC/DC options. This is a great balance for compute, storage, and add-on cards in a 1U and 2U rack mount. The Big Twin offers big features in the 2U rack mount. With the options of having either 2 or 4 hot swappable nodes, it gives you a huge compute density play in the 2U enclosure. Each node has a variety of storage in the 2.5-inch or 3.5-inch size while supporting a mix of NVMe, SATA, and SAS, as well as flexible networking through our SIOM module. Our Big Twin platform was one of the first twin solutions to offer you the density in a 2U without sacrificing the performance. Each node will support up to 2 dual Xeon processors at 205 watt as well as 24 DIMMs for up to 6 terabyte of memory. You have a variety of storage with the latest implementation of EDSF short, allowing up to 10 NVMe drives per node. Each node will support our new SIOM, which will allow the ultimate flexibility of networking options without taking up an expansion slot. In regards to the expansion slot, you will have 2 PCI Express slots on each node. Each platform is equipped with a redundant power supply. If you are looking for storage, look no further than our Super Storage. We have a 1U to 4U form factor that will give you a wide range of storage options in either server or JBOD configurations. If your application needs more storage capacity, we have a 4U top loading to accommodate 40 or 63.5-inch drives. If you have limited space, we have our Simply Double server that will allow you to maintain the standard 2U rack mount with an innovative design to support 48 2.5-inch drives in NVMe or SATA and SAS. Some of our newest designs feature NVMe storage to reduce the latency and maximize the IOPS and throughput. We provide a unique design in a 1U to offer you a petascale of solid-state storage with either 36 EDSF short modules or 48 2.5-inch NVMe drives.
I'd like to recap the Supermicro and SUSE partnership business value proposition. All Supermicro hardware is going through SUSE ES certification program and make sure the system is 100% compatible with SUSE software. Additionally, Supermicro open platform modular design can easily meet customer special requirements for computing, networking, and storage. We also resell SUSE consulting service and the SUSE enterprise level technical support. The key takeaway message here is Supermicro is a one-stop shop for SUSE CaaS platform solution, consulting, customized training, rack integration, and enterprise level tech support. Here are the quick steps to get your SUSE CaaS platform POC environment up and running within 10 minutes. Step 1, prepare and install OSs, load container-related packages, configure SSH connections to all cluster nodes. Step 2, bootstrap the cluster by setting up a first master node and add the first worker node. Step 3, deploy applications with Kubernetes client. Please note the option -kupa-config. It is to tell the Kubernetes client which cluster namespace you want to work with. The following 2 video clips are going to show you how fast the processes are.
This is the first clip to Bootstrap cluster. This is a real-time recording. You can get watch out and time it. It's about 2 minutes. Look at the bottom. It says it's taking about 4 minutes. Actually, it's taking about 2 minutes, under 2 minutes. Right now, I think it's checking in with Kubernetes repositories. Making sure all the packages pull down to the local machine before the installation starts. So it's take a little time there. Depending on how fast your internet is, right? So because it's repository, the demo environment, actually I'm pulling Kubernetes package directly from Kubernetes software repository. Also, the SUSE package, it's directly from SUSE over the internet. There you go. Let's start the process to install. I think they got all the packages in there. This is just me making sure the session is still live. I just use my mouse, scroll up and down. Yeah, it's waiting. Here you go. Yeah, it's kicking in. The installation process is creating all the namespaces, for the system and all that. Yep. And still going. There we go. It's done. You successfully bootstrap your first master. So the cluster is up and running. The second part of the video clip shows you how to add a worker node into the cluster that we initialized in the first part of the video. Just pasting my command, off you go. They starting retrieving packages from a SUSE repository and as well as Kubernetes repository, and then install the packages to the worker nodes. There you go. Still working on that. And give a couple of seconds here. Once it's finished, they'll show you the worker nodes successfully join the cluster. Here you go. Yep. And then you can do a scuba cluster status command to show this entire cluster status. Here you go. The master and the worker nodes is both up and running. So it'll totally take about 5 minutes or less. With that, I conclude my demo. Thank you very much. We really appreciate your time here spent with us today. If you have any questions regarding to this presentation at all, please do not hesitate to contact us. Both Jerry's and my email address are listed here. We're here to help. We're here to help you and your customers to build a Supermicro hardware-based solution that offers the best combination of price and performance to do more with less. For more information about Supermicro, please check out our website, www.supermicro.com. Thanks again. Hope you all enjoy SUSE Digital Conference.
Learn more at supermicro.com, powered by Intel.